This is a brief review of how transformations affect parent functions, and we're not even going to graph today. We can focus on graphing in class. I just wanted to run through the three basic transformations that you were familiar with last year and remind you of how they affect the given function. So we're going to assume that we start with a parent function, f of x, and I'm going to try to keep this general until the example. So a translation, if I applied a translation to that function, I can add positive or negative values to the inside of the function and to the outside. And what that would do, inside the function is what I call counterintuitive. It behaves the opposite of the sign you see. So this would move to the right by h, move to the right h units, and up k units. So it translates the function, it just scoots it to the right by h units and up by k units. An example of this, if I have the parent function is x squared, and to that function I applied this plus 3, it would look like this, x plus 3, that whole thing squared. Since the 3 is inside the parentheses, this is inside the function, so that means it would shift f of x, it would shift y is equal to x squared to the left by 3. It's counterintuitive. The second type of transformation is a reflection. We can reflect, if we're given the parent function f of x, we can reflect outside of the function or inside. When we reflect outside, we are basically multiplying all the y values by a negative 1. We are negating the y values. So this reflects over the x-axis. It reflects down over the x-axis. And when we are multiplying by a negative 1 to the inside, that reflects it over the y-axis. If I think of a parabola again, and I start with f of x is equal to x squared, when you think about it, if I apply this reflection, I'm going to change that. If I apply it and make a negative f of x, that means it's negative x squared. Well, we know when the coefficient in front of the x squared term is negative, the parabola opens down. And that's essentially what this reflection does. Every y value is now negated, and the parabola will open down. So for dilations, we're going to focus on the dilations that are outside of the function. So I have some kind of a coefficient, and I'm going to multiply the entire function by that. This directly affects the y values. So we have two cases. We have the case where a is greater than 1. That means I'm multiplying by a big number, like 2 or 3 or 4 or 4.5 or whatever. And what that does is that is a vertical stretch. A vertical stretch by a factor of a. And then the other case is when a is less than 1. It's between 0 and 1. And what that does, it shrinks, it chops all the y values by a certain number, and that's a vertical shrink. A vertical shrink by a. And those are the two that we're going to focus on this year. When you get up to algebra trig or pre-calculus, you'll focus on the inside dilations as well. So here we have a numerical example for you. I have f of x is equal to 2x squared. So to the parent function x squared, I'm applying an external dilation of 2. What that means is I'm taking every single y value and I'm doubling it. So this is a vertical stretch. By 2. And we have to be careful if we have a reflection with it. Let's say g of x is negative 1/2 x squared. This is a reflection. This is not a dilation, so we don't say vertical shrink by -2. This is a reflection. This is a dilation. So it would be reflecting down, reflect over the x, over x-axis, and it would be a vertical shrink. By 2. So finally, we're just going to describe what's going on with these 4 functions that I have here, and I've only applied a single transformation to each one, and we can do some more complicated examples in class. The first one, I am subtracting 2, or adding a -2, however you want to see that, inside the function. So this is going to shift everything right by 2 units. By 2. It's counterintuitive. If it's -2, it's going to move to the right. The second example, I'm adding 3 to the outside. This is a direct read, so I'm going to shift up by 3. If I'm adding 3 to the outside, I'm moving up. The third one, I'm reflecting over the x, because I'm reflecting down. I'm negating all my y values. I'm reflecting down. And the fourth one is a fractional coefficient in front of the function. So I'm taking every single y value and I'm chopping them in half. So that is a vertical shrink. Oh my goodness, I didn't spell vertical right in the last page. Vertical shrink by 2.